Day 259 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 79, word search. The difficulty level is medium, but don't worry, we're going to keep the solution as simple and easy to understand as possible because we're all here on different levels of our programming journey, and we want everybody to be able to understand the solution at the end of this video. So, let's get into the question and see what it says. It says, given an m by n grid of characters board and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once. All right, so let's look at example one so we can break that down. In example one, the input board equals m by n matrix grid, right? With the first row being A, B, C, D, E, or A, B, C, E, the second row being S, F, C, F, S, F, C, S, and the third row being A, D, E, E. The word we are looking for is A, B, C, C, E, D, and the output is true. The output is true because, as you can see, we can form the word A, B, C, C, E, D by connecting these cells right here. We go A, B, C, then we go vertically C, E, then we go horizontally D, right? And it says up here, the word can be constructed from letters of sequentially adjacent cells where adjacent cells are horizontally or vertically neighboring. So in this case, we're using adjacent cells that are both horizontally and vertically neighboring, right? This is horizontally, this is vertically, and this is horizontally again. So as we can see, the cells or the letters do not have to be in a straight line. They could go in different patterns, horizontally or vertically. As you can see, diagonally does not count. They have to be vertical or horizontal adjacently, right? So let's look at example two, where it's a little bit less letters, but same principle. So let's look at it. Example two, we have the input board equals a 2D array of integers, right? With the first row or n by n matrix grid, with the first row being A, B, C, E, second row S, F, C, S, and third row A, D, E, E. This time the word is C. So we want to see if we can spell the word C from these cells or letters that they've given us, right? And as you can see, the output is true, no pun intended. And we can spell it like this, S-E-E, right? We go down vertically and then we go horizontally to the left. And all of these cells are adjacent to each other, so it works, right? We go S-E-E, boom, just like that. So let's look at example three, where the output will be false and we will not be able to spell the word. So in example three, we have the same thing to the array n by n matrix grid, with the first row being A, B, C, E, second row being S, F, C, S, and third row being A, D, E, E again. I think that's the same. Okay, so it's the same grid for all the examples, right? Then this time the word is A, B, C, B, and the output is false, and that's because there's no way for us to spell this word A, B, C, B, right? We have A, B, C here, but we're not allowed to go back, right? It says up here that the same letter cell may not be used more than once. So if we try to use this B again, we would be using the same letter cell more than once. We could go A, B, C, but we can't add that extra B because we already used this B. We would need another B either here or here, and there is no B here or here, so we can't spell it. And thus, since we cannot spell it, the output is false. So now that we understand the question, y'all, let's get into the solution. But before we get into the solution, y'all, do not forget to like, comment, and subscribe. Now, let's get into it, y'all, the fun part. So the first thing we need to do, we're going to create a struct that's going to represent a cell in the grid, and we're just going to, so we could do that by, let's see how we're going to do this. So yeah, we come right here. The struct is going to be in the class. We're going to say struct. We could just call it cell. So colon. We're going to make it hashable. Open up the brackets. And then we can identify the rows and the columns by saying we're going to say var r, that could be for row, and that's going to be an integer. Then we'll do column, same thing, we'll say var c, that's going to be an integer as well. And remember, once again, this is going to we're going to use this to represent each cell in the grid. Now let's get into the function, right? And the first thing we need to do is define the valid range for the rows and columns. So in order to do that, we need to create another variable. This time we're in the function, the main function that they give us. We're going to say var rows equals, then we're going to say 0 up to ... less than sign board dot count. Boom. Then we're going to do the same thing for columns. This time we're going to say var calls equals, this should not be, this should be a 0, equals 0 ... less than board square bracket 0 count. And once again, this is going to define the range for the rows and the columns. Now we need to convert the word into an array of characters, which will allow us easier access when we're trying to find these characters, right? So in order to do that, we're going to say var word colon, not colon, we're just going to set that equal to an array, open up the parentheses of word. Boom, just like that. Now we need a set to track the cells that have already been visited during the search. So in order to do that, we declare variable. We could just call it scene, meaning we've already seen these characters, and we can say, or not characters, but cells. We can say set less than, then we could, this is where we put in our cell, then we put greater than, and initialize it with 2 parentheses like that. So it's going to be a set of cells that we created up here, and we're going to, this should be equals. So it should be set equals a set of cells, or var scene equals a set of cells. Boom. Okay, so now let's get into it. We're going to use a depth first search for this with a D as in dog, depth first search. So in order to do that, we're going to use a helper function. So we're going to create the function here, still inside the main function. We're going to create our helper function. We could just call it DFS, open up the parentheses, and we'll say underscore R colon. That's going to be integer. Then we'll say comma underscore C colon. That's going to be integer as well. And then we'll say underscore I colon, and that's going to be an integer as well. And we are going to return a boolean, just like this. Boom. Okay. So now we need a base case to check if all characters in the word have been matched. And if it is, then we can return true, right? So if we matched all of the characters in word, then that means we can just return true because we've created the word that we've been looking for, right? And this is just the base case. So we're going to say if I equals word dot count, then we're just going to open up the brackets and we can say return true, just like so. Now we need to check if the current cell is out of bounds or does not match the current character or has already been visited. So in order to do that, we're just going to say if exclamation point rows dot contains, open up the parentheses R, then we're going to say or. So then we'll say or exclamation point calls dot contains, open up the parentheses C, or board square bracket R, come outside that square bracket C, come outside that square bracket, exclamation point equals word square bracket I, or come outside those square brackets, or one more or, scene dot contains, open up the parentheses, cell, open up more parentheses, R colon R, comma C colon C, then we could just return false. So come outside those parentheses, and then we could say return false. My bad, y'all. Let's clean this up a little. Oh, let's clean this up a little bit. My bad, y'all. My bad. Let me see what is going on. So let me bring this over here. My bad, y'all. No, that's not gonna work. So we just keep it like this. Just keep it how it is. We ain't gonna get too fancy. Alright. Boom. Now, what we want to do, or we could open this up at least. See what that. No, I don't like that. Alright. Now let's keep going, y'all. Let's keep going. My bad, my bad. So now we need to mark the current cell as visited, right? We need to say scene.insert. Remember, scene is keeping track of our visited cells. So we say scene.insert, open up the parentheses, then we're going to say cell, open up the parentheses again, R colon R, comma C colon C. Boom. Now it's time to explore all 4 possible directions, down, up, right, up, and left, right? So in order to do that, we're just going to come down here, and we are going to say let res equal DFS, open up the parentheses, R plus 1, comma, C, comma, I, plus 1. Come outside those parentheses, we'll say or, and we could just come down here. So that's going to check down. Now we need to check to the right. So check to the right, we're going to say, DFS, open up the parentheses, R, comma, C, plus 1, comma, I plus 1. Just like that. Now we need to say or, because we're not done yet. Bad, let me just see. Alright. Now we need to say or. Now we're going to do now we're going to check up. So we're going to say DFS, open up the parentheses, R minus 1, comma C, comma, I plus 1. Boom. Then we're going to say or again, last one, because we need to check to the left. We're going to say DFS, open up the parentheses, R, comma, C minus 1, comma, I plus 1. Boom, just like so. Now it's time to get into the backtracking. So we need to remove the current cell from the visited set so we can allow other paths. So in order to do that, we're just going to come underneath this, and we are going to say scene.remove, open up the parentheses, cell, open up the parentheses, R colon R, comma C colon C. Make sure that's right. Boom. Now we could just come down here and we can return whether any of the recursive cells found are going to form a valid path. So in order to do that, we could just say return res. Boom. Now, we're not done yet. We're getting there though. We're going to come outside of this helper function now, and we're going to say we need to iterate through every cell in the board as a potential starting point, right? So in order to do that, we're going to say for R in rows, open up the bracket. Then we're going to say for C in calls, open up the bracket. We need to see if a valid path is found starting from the cell either R or C, then we can return true for this, right? So we're going to say if DFS, open up the parentheses, R, comma, C, comma, 0, we could just say return true, just like that. And if no valid paths are found for the entire board, we can just return false. So that means we just come right here and we could say return false, just like so. So let's run this, y'all. Make sure it runs like it's supposed to. before we submit it. Let's see. Oh, okay, line 16. What's going on? Oh, see, sorry, we didn't return that right. So let's return it. Boom. Let's run it again. Let's see. Fingers crossed. Okay, let's see. Cannot, what line we at? Line 20, excuse me, line 19. Cannot find rows and scope. So sorry, y'all. This should be rows, not row. So let's run it. Sorry, it should be row, not rows. Sorry about that. Let's see. Once again, same thing. Should be row, not rows. Let's run it again. Let's see. And it's accepted, y'all. So let's submit it. Make sure it stays accepted after we submit it. Let's see, y'all. Let's see. Ooh. 1,525 milliseconds beats 30.89% of users with Swift, y'all. It's not too bad. Excuse me, y'all. We want to get those numbers up, but right now we're just focused on being able to find or being able to solve the problem that's been put in front of us, right? So in order to do that, we want to have a solution that we're able to understand and we're able to explain, right? And that knowledge that we've gained from these easier solutions we'll be able to apply further down the line to further questions that we may come across, which will help us in our overall goal of being able to solve these LeetCode problems. But don't worry, as we get better at these LeetCode problems, the time complexity will get better as well. Right now, we're not really focused on the time complexity. We just want to be able to solve the problem and have the knowledge and understanding to be able to solve the problem. And that will put us ahead of a lot of people just being able to solve the problem. So get one more look at the code. One more look at the code before we leave, y'all. I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.